I welcome you all for this lecture series on artificial intelligence and machine learning. In this lecture, we will briefly discuss about the algorithm called decision tree classification algorithm. First, we should know why we should learn this decision tree classification algorithm. The learning decision tree classification algorithm in artificial intelligence and machine learning is important because they are simple, intuitive models that mimic human decision making. They are easy to interpret and explain, making them useful for transparent AI systems. Decision trees also serve as the foundation for more advanced algorithms like random forest. Additionally, they handle both classification and regression tasks with minimal data pre-processing. We'll see one by one. First, we'll see the introduction to decision trees. A decision tree is a supervised machine learning algorithm. All we know that it is a supervised machine learning algorithm, and it is used for class. There are two purposes. It will be we are using it: classification and regression. Decision trees fall under the supervised learning techniques, meaning they require labeled data to train the model, and they can handle both classification problems where the goal is to assign labels and the regression problems where the goal is to predict continuous values. This will make them widely applicable in many domains, and it uses this decision tree algorithms. It uses a tree like model of decisions based on future values. The structure of decision tree resembles a flowchart or a hierarchy where each node represents a decision based on a specific future values. This structured flow allows the algorithm to break down complex decisions into simpler sequential ones which are easier to follow and compute. And each internal node represents a test on feature. Each branch represents the outcome of the test, and each leaf node represents the final decision or prediction. In a decision tree, internal nodes pose conditional questions about a feature. That is age is greater than 50, less than 50, etc. And each branch from that node leads to a different outcome of the tests. This branching continues until a leaf node is reached, which provides a final outcome, either a classification label or a predicted value. And the decision trees, in this case, the decision trees are easy to interpret and visualize and explain. How means one of the major advantage of decision trees is either their interpretability, since they mirror human decision making processes and are structured clearly. They can be easily visualized and explained to both technical and non technical stakeholders, making them ideal for use in transparent, explainable AI systems. And there are two key types of nodes. What are they? There are two fundamental types of nodes in a decision tree: the decision node and a leaf node. A decision node is where the model splits the data based on future values using the decision rule. A leaf node, on the other hand, gives the final decisions or predictions and has no further splits or branches. And the decision node, what it will do is it splits the data based on the conditions. A decision node asks a question about one of the data's features. Based on the answer, the data is divided and passed along different branches. This is the core mechanism through which the model filters data and learns decision paths. Next, the leaf node, if you are considering final output, no further leaf node, final output, no further splits in this case, as I've said. Once the data cannot be split further meaningfully or stopping criterion is met, like max depth or minimum samples, a leaf node is created. It stores the predicted output and marks the end of the particular decision path. And here to build the tree, we are using the Technica. And the another one more thing what we should learn here is the goal is to build the model that predicts the target classes or values using the rules learned from the training data. How it has been done? The primary objective of building a decision tree is to develop a model that can generalize from training data and accurately predict the target variables for new unseen data. This is achieved by recursively splitting the data based on features that provide the highest information gain, and here the gain plays an important role in this will be seeing in the problem. And highest information gain or lowest impurity. Next, to build the tree, we have to use the CART algorithm. CART means classification and regression trees. The CART algorithm is a standard techniques for constructing decision trees. It uses measures like it will be using various measures, Gini index, or mainly we are using entropy. Entropy to determine the best features to split on each node. CART builds binary trees. Each node has two children and works for both classification and regression tasks, making it a foundational algorithm in decision tree learning. So here we are using for making for constructing the decision tree, we are using various terminologies. The first one is the root node. And the root node is the starting point of the decision tree and it represents the entire data set before splitting. And leaf node means the terminal node, the final node. This is the final node, terminal node that gives the final output. No further splitting occurs. Splitting means dividing a node into two or more sub nodes based on conditions. Branch or subtree, a section of the tree resulting from splitting node. We'll see one flow chart for this. Parent or child node, a node that splits is a parent, the resulting node or children. And pruning, you know that what is the function of pruning? The process of removing. Pruning means removing unnecessary branches. What is the purpose of reducing the unnecessary branches? To reduce the model complexity. And working of a decision tree algorithm, it starts at the root node, begin the entire data set at the root node, and we have to select the best attribute by using the attribute selection measure information gain to identify the most informative attributes. And we have to split the data set, divide the data set into subsets based on the selected attributes possible values. And we have to create a decision nodes. It has generate decision nodes for each subset. And recursive process, apply the above steps recursively to each subset until no further splitting is possible. So that means what? Resulting in the leaf nodes. And this is the an example of the tree, the decision tree structure. Decision node, we are calling it as the root node. Then it has got two subnodes, a decision node and a decision node, and this has got two leaf nodes. This we can call it as the subtree. And here it has got one is the leaf node, another one is the decision node. Decision node means it has to split again into the leaf node until we get the final output. So this is what to be the general process of this the decision tree structures. And why we have to use this decision trees? It is mimic to the human thinking. That means the decision trees simulate the way humans make decisions, making them intuitive and logical. Without emotions, all can whatever the man can do, the machines can able to do it. So that only we can call it as mimic the human thinking, and we can be easily able to understand the tree-like structure visually represents decisions, making the model simple to interpret and explain. So visualization will always makes us easy to understand. And this is the best example for the tennis data set. The decision tree tennis data set. This is this table, and the decision tree tennis data set is a popular example used to illustrate the concept of decision trees in machine learning. This data set typically consists of features. What are all the features we are using? Outlook, temperature, humidity, wind. These are all the various features we are using, with the target variables being whether to play tennis or not. Play tennis or not. The data set is useful for understanding decision trees because it provides a simple and intuitive way to visualize and interpret the decision making process. By analyzing this data set, one can see how a decision tree model splits data based on feature values, recursively creating branches and leaves that ultimately lead to a predicted outcome, making it an excellent tool for grasping the basics of decision trees and their applications in classification problems. So here there are 14 days. It has got a features, as I said, temperature. In this we are going to find out we are going to do some calculations. First we are going to find out the information gain. For that, before going into that, we are going to find out the what is entropy, and we need to know what is entropy. Why should we find out this entropy? And all you know that entropy is the measure of impurity or uncertainty in the data set. If all the instances belong to the same class, that is all yes or all no, the entropy value is 0. If the data set is 50% yes, 50% no, the entropy is the maximum value 1, and the value of entropy is given by, the formula for entropy is given by entropy of S equal to the formula, you know that here the plus, this is the positive value, or yes we can say, or 1 or high we can say, log 2 of this p plus this value we have to write it over here, and minus of p minus this minus and this minus value we have to write it over here. And this b plus is the proportion of yes, and b minus is the proportion of no. And for the given data set, we have to calculate the entropy of the full data set. So from the play tennis data set, how many data are there? How many records are there? 14 records, right? 14 records are there. In this, how many no's are there? How many yes? Yes, if you are calculating 1, 2, 3, 4, 5, 6, 7, 8, 9. The remaining no's are how many values? 9, remaining 5. 5 values are as a no. So in this, so how many records are there? Totally 14 records are available. S is equal to 9 and no is equal to 5. For this, first we have to find out the entropy. So entropy is given by the formula what? Minus P of plus log 2 P plus, and vice versa, P minus log 2 P minus. So in this case, we have to write how many, the P plus is what? P plus, how many records are there? For the 14 records, S is only 9. For 14 records, how many no's are there? 5. So we have to write 9 by minus 9 by 14, log 2 of 9 by 14, minus 5 by 14 into log 2 of 5 by 14. So if you are calculating, we are approximately getting the value 0.94. And we have to choose the feature. Let us consider the first we have to use, we will use the outlook. So in this outlook, how many variables are there? Sunny, overcast, rain. In this, so sunny, how many records are there? If from the table we can find out how many records are there. 1, 1, 2, sunny, 3, 3, 4, and 5. So in this, how many Sunny is having how many S's are there? There are 2 yes and 3 no's are there. No. From this we have to calculate. So 5 records are available: D1, D2, D8, D9, D11. And overcast, if you are looking into D2, D7, D2 here. See overcast. This is overcast. This is overcast. and this is overcast, this is overcast. 4 records are available. And rain is, if you are taking, how many rains are there here? This is 1, 2, 3, and here 4, not 1, 2, yeah, 3, sorry, 3, 4, and 5 records are available. For each rain, where we have to find out yes or no. So in this case, 5 records each there. So we have to calculate the entropy for each group. For this, all those things we have to find out the entropy. So yes, first if you are taking Sunny, there are two S's are there. No, Sunny, if you are taking here, Sunny D2, there is Sunny D9 and D11. D9 and D11. See here, yes. And D11, yes. So another value, other values are no. For this entropy, how we have to find out how totally 5 Sunny values are there. S is 2 and no is 3 divided by 5. So if you are substituting, we will get 0.971. Similarly for the other values, overcast, how many values are there? So all four are yes. So if you are looking into the table, all four values here, this is one for the overcast, this is one overcast yes, and overcast yes, overcast yes. So only one value we are going to get. What is the value we are going to get for the entropy is -1 log to 1. Mine here it is 0. It is 0. How? 4 values, 4 divided by 4. We can write it as 1. So this entropy value for overcast is 0. And rain, 5 records are there. Yes is 3 and no is 2. So 3 by 5 into this value, and here 2 by 5 log 2 of this value. Here we are getting 0.971. And combine the entropies, and we have to find out the, we have to get the information gain. What we are going to get? Information gain we are going to get. So in this case, information gain in the sense what? What is the information gain here? So gain S, comma outlook. Outlook only we have taken. Entropy S. Already entropy we have found out, right? 0.94, and the summation of modulus of SU divided by S, variables, the attributes, dot entropy V. So first entropy, the general, for the Sunny, what is the total numbers? Modulus of sum, there are 14 variables are there. And for Sunny, if you are taking 5 variables, here SU, SV, 5 divided by 14 into the entropy value, what we have found out. So 0.91. Next, what is the value we found out for overcast? 4 divided by 4. The entropy value is what? Here the entropy value is 0. And here we are getting the value is equal to 0. For rain, what is the entropy value? For rain, the entropy value is 0.971. 0.971. So the gain is given by, that is 5 divided by 14, 97 into 971, you are getting 347. The gain S comma outlook is given by entropy. General entropy values we have found out 0.94, and we have to add all those values. 0.347 plus 0 plus 347. So if you are adding all those values finally and subtracting from this 94, we are getting 0.246. And we have to do the same process for whatever the other parameters in this table, temperature, humidity, and also wind. So I directly found out the values. Learners kindly do the step for each and everything. The humidity, the gain is given by 0.151. Wind, the humidity is given by 0.048. Temperature, the gain is 0.029. So comparing to all those four features, so from the outlook, what we have got? 0.246. Outlook we have got 0.246. So comparing all these four values, outlooks only gives the maximum gain. So from the data, from the classification data set, Outlook gives the best information gain. So it has been chosen as the root node. How we are calling it as the best root node? And Outlook gives the maximum gain value. Based on the gain, we are choosing the parent node. So Outlook, we are choosing it as the parent node, and that is a root node. And here for Outlook, the overcast, we are going to take all the results are yes. The leaf nodes, we are giving it as yes. For the Outlook, if it is a rain, apply for further splitting. Example on the wind, it based on the rain will be based on the wind. Wind may be weak or wind may be strong. And for the Outlook is sunny, and we have to use the sunny can be divided into based on the variable called humidity. Humidity is high, yes or no, and humidity is normal, we can call it as yes. So based on that, we are forming the, so what we have found out, this is the root node. This is the root node, and overcast we found out the value is yes, and sunny we have got various values, humidity and wind. And wind we have two values, high and normal. If high is no and or normal if it is yes. And wind is strong, yes or no, no. And wind is weak, yes. So in this case we can able to, so finally we are coming to the conclusion that if finally we are getting the humidity is final result is no, and it is normal, and wind is it is strong enough, it is not there, and weak wind we are having it. In this case we can able to play the tennis. Hope everyone understood the concepts of the tennis playing algorithm in terms of decision making. And coming into the conclusion, and it is mimic to human logic. Decision trees replicate how humans naturally make decisions by following conditions based reasoning. And it is the intuitive design. Their structure aligns with the human thought processes, making them easy to follow. And visual clarity. So based on this tree, we can able to say what should be the output, so that only we can call it as it has got a visual clarity. The tree diagram clearly represent each step and outcome, enhancing the transparency. Easy to interpret. Even users without technical expertise can understand and explain the model. And effective communication tool. These decision trees are ideal for presenting models to stakeholders due to their simplicity and clarity. In this case, in this slide, we have used the tennis table example. It is common example like predicting the weather to play tennis based on the weather conditions, and we have to take the decisions based on the weather conditions, and it is relatable and easy to learn. Hope everyone understood this simple basic algorithm of decision tree. The remaining things we will discuss in the next class. Thank you.